Good afternoon and peace be upon you. Ladies and gentlemen, welcome to Lab Asia 2022 seminar session with Thermo Fisher Scientific Pte. Ltd. Reliable analysis of ethylene oxide and 2-chloroethanol in food samples using gas chromatography mass spectrometry. Before we start our session, there are a few rules that we have to adhere. If you have any question, please wait for the Q&A session or do list them down at the Q&A box. If there's any internet disruption during the session, kindly be patient and try to sign in again. In this session, we have Dr. Lucas Rasky. He is a product specialist at Thermo Fisher Scientific. He holds a PhD in analytical chemistry and has over 10 years of experience in pesticide residue analysis. Dr. Lucas is an expert in method development and has co-authored numerous scientific papers dedicated to pesticide residue analysis. With that, ladies and gentlemen, let's welcome him today. Over to you, Dr. Lucas.
Okay, thank you very much for that kind introduction. My name is Łukasz Rajski. I work at Thermo Fisher Scientific as product specialist, and I'm going to talk about analysis of ethylene oxide and 2-chloroethanol. However, before I start to talk about ethylene oxide, I would like to shortly present you our GCMS portfolio. Maybe you don't know, but in March this year, we introduced 4 new GCMS products. We showed new gas chromatograph. This is Trace 16 series. We have 2 instruments, 1600 and 1610. We showed new liquid autosampler, AS 1610. Our new single quadrupole mass spectrometer, ISQ 7610, and new triple quadrupole mass spectrometer, TSQ 9610. Beside that, in our portfolio, we have also an advanced autosampler, Triplus RSH Smart, and of course, our high resolution instrument, Orbitrap Exploris GC. In Trace 1610 GC, you will find many features that will enhance your interaction with the system, because we have a new high-resolution touchscreen. We have a multi-language menu, instrument health icons, consumables usage counter, automatic leak detection. We have diagnostic information and a USB port. In the touchscreen, using the touchscreen, the menu, you will find how-to videos. So if you have a problem, if you have any doubt, if you don't know how to perform some kind of maintenance, if you don't know how to replace the injector, how to change the column, how to change the liner, you can go to the touchscreen, and there you will find a tutorial video that will show you step by step how to perform the action that you want to do. Also, we have tool-free iConnect column lock. It's the system that helps you to connect in an easy way the column to the injector. In Trace 1610, we have something what maybe you will find funny, but our customers love it. We have illuminated GC oven. So we have light inside. It's when you open the GC oven door, there is light inside. We have tubing free inlet design and integrated backflash. On this slide, you can see the TSQ 9610. This is our triple quadrupole. And when we were designing this instrument, we had 3 goals. We wanted to increase the instrument uptime. We wanted to maximize the sample throughput. And also we wanted to provide you a rapid return of investment. To achieve those goals, we introduced some very interesting features. We have new features on the hardware side as well as on the software side. Let me start from the hardware. First of all, we have a never vent AEI. What is never vent? What is never vent technology? Never vent technology is something what you may know from previous generation of our instruments. However, previously never vent technology was available only with our basic, with our standard ion source with extractor. Right now we have never vent technology with advanced EI. Never vent technology is a technology that allows you to replace the ion source, replace the filament, change the column without venting the instrument. And as I mentioned, now we have never vent with advanced EI. Advanced EI is our high end, our very sensitive ion source. Also on the hardware side, we have a new detector, new generation detector. We call this detector XLXR. It means extended life, extended range. And the name tells you everything. This new detector has a broader linear dynamic range and also extended lifetime. Probably you know that if you use your single quad or your triple quad 24/7, you have to replace the detector after maybe 2 years. However, with our new detector, with XLXR detector, the lifetime is 7 times longer. It means that we can assume that the lifetime of the detector is even longer than the lifetime of the instrument. On the software side, we have native chromeleon driver, because previously, if you wanted to change the temperature of the ion source, if you wanted to change the temperature of the transfer line, you had to use a separate piece of software that was called dashboard. We don't use the dashboard anymore. Now we have native chromeleon driver. The chromeleon, you have a special tab when you can control the mass spectrometer. When you can change the temperatures, you can check all the readbacks. We have a new feature that is in sequence tuning. So if you have a very long sequence, you can program some ion source tuning in that sequence. We have language localization. Also on the software side, we have a instrument health feature that will help you to prevent the necessity of the system maintenance. I mentioned about the never vent technology and the amount of time that you can save thanks to that technology. Here you have a table with 3 very important maintenance activities: column change, exchange of the ion source, and replacement of the filament. As I mentioned, with never vent technology, you don't have to vent the instrument to perform that activities. So as can you see in the table, you can save around 90% of your time thanks to the never vent technology. I mentioned also the extended dynamic range of the XLXR detector. And here you can see an example. On the left-hand side, we have a calibration curve that was acquired with our previous generation detector. And there is no doubt that those 2 points that are marked with red circles, they are out of the linear range. However, the same vials analyzed with the new detector, we see that all the points, they fit perfectly into the linear model. So we can summarize that with our new line of instruments, we have increased the instrument uptime because thanks to the never vent technology, because you don't have to vent the instrument so often, and then you don't have to pump down. You can maximize the sample throughput because you have now broader dynamic range of your detector. In case of narrow detector dynamic range, Sometimes you have a sample that is outside of your linear range. It means that you have to dilute and reinject the sample. However, thanks to the extended dynamic range, this situation will not happen so often. And finally, thanks to our smart tuning and other software solution, you can plan better work in your laboratory. Okay, so after this software related introduction, now we can talk about ethylene oxide. Well, what is ethylene oxide? Ethylene oxide is a substance that has many applications in the industry. However, from our point of view, the most important is that ethylene oxide is used for the fumigation of dry food commodities. We have to also remember that ethylene oxide can have a negative impact on the human health. So we have to control the concentration of the ethylene oxide in the food. Typical commodities that are fumigated with ethylene oxide, as I mentioned previously, they are mainly dry commodities, because here we have herbs, spices, nuts, dates, raisins, oily seeds, milled cereals, feed, or even milk powder. In Europe, in the European Union, we have something what is called Rapid Alert System for Food and Feed. This is the network, the system that helps, that allows to official laboratories communicate any problems related to the food safety. And in this year, in 2020, in the European Union, we have had 124 notifications, 124 alerts related to ethylene oxide. And ethylene oxide, you can see the list of the matrices where ethylene oxide was detected only by the official laboratories. So again, the list is very long, that we have some spices, seeds, even food supplements and ice creams. Ethylene oxide is a substance that is not very stable. Typical degradation products that you may detect are 2-bromoethanol, 2-chloroethanol, and ethylene glycol. However, in the European Union, the residue definition that we have, that residue definition covers only two substances, ethylene oxide and 2-chloroethanol. So the residue definition that we have in the European Union is that the ethylene oxide is a sum of ethylene oxide and 2-chloroethanol expressed as ethylene oxide. On this slide, we have physicochemical properties of both analytes, ethylene oxide and 2-chloroethanol. Please take a look that ethylene oxide has a very low boiling point and very low molecular mass. And when we analyze ethylene oxide, we have many analytical challenges, because the low boiling point, we may expect some losses in the extraction, and also poor retention in the chromatographic column. Low molecular mass of ethylene oxide means that we will have non-selective transitions. And finally, the third challenge is not related to the ethylene oxide body itself, but to the matrices. Because I mentioned previously that the ethylene oxide is used mainly to protect dry commodities. And you know that when we extract a dry matrix, the extract that we obtain is dirty. There is a huge amount of co-extracted substances. It means that we can expect some interferences. It's obvious that if we have more substances in our extract, it means that the probability that one of those substances will have the same transition as our analyte is higher. Also, dirty extracts of dry matrices are very challenging for the instruments from the robustness point of view. On this slide, you can see the method that we use to analyze ethylene oxide. In case of instrumentation, it was obviously our new Trace 1610 and TSQ 9610. The column that we used, it was TG 624 SEAL MS. In the central part of this slide, you can see the oven program. The total runtime was 16 minutes, and on the right-hand side, we have a table with the transitions. And as I mentioned before, ethylene oxide is a very small molecule, and the transitions that we have are very non-selective. So you can see here that it was 44 to 14 and 44 to 29. Sensitivity. Sensitivity is a very, very important parameter. Our customers, they always ask us about sensitivity. And thanks to the advanced EI, our system, our triple quadruple, our single quads, they have very good sensitivity. On this slide, you can see 2 ppbs of ethylene oxide and 2 ppbs for 2-chloroethanol. And what is important, it was the injection volume here was only 1 microliter, and injecting 1 microliter, we were able to obtain, I would say, satisfying signal to noise ratio for all the transitions. I mentioned before about possible interferences, and when you work with those dry matrices with sesame seed and other dry matrices, one of the most typical interfering substance is acetaldehyde. Acetaldehyde has exactly the same transitions as ethylene oxide. So the only way to distinguish between those two substances, to avoid problems, to avoid interfering action from ethylene from acetaldehyde, is to separate acetaldehyde and ethylene oxide. With our method, with the column that we applied, with the oven program, we were able to separate those two substances. And as you can see on the slide, that the difference in the retention time between those two substances was 0.14 minutes. So it was higher than 0.1 minute. Linearity. I mentioned that our detector, XR detector, had a broader linear range, and the linearity we tested in the range from 2 ppbs up to 5 ppm. This is the concentration in the vial, from 2 ppbs up to 5 ppms. And as you can see on the slide, the R square was 0.9996. Here in Europe, when we evaluate the linearity, we take into account deviation of back calculated concentration, and it should be below 20%, or it should be in the range minus 20% plus 20%. You can see in the table that it was no problem with the linearity, no problem with back calculated concentration, and also the ion ratio was stable, because this is also one of the identification criteria that we have, that when we work with a triple quad, we have to control the ion ratio. The ion ratio variation cannot be higher than 30%. In the case of the method that we had here, the acceptable ion ratio is between 4.9 and 9.1, and you can see that for all the points of our calibration curve, the ion ratio was in the expected range. Here you can see linearity for the ethylene oxide. Again, deviation of back calculated concentration below 20% and ion ratio in the acceptable range. Here for the 2-chloroethanol, the ion ratio was very close to 100%. So this acceptable range was between 70 and 130%. On this slide, you can see some results of real sample analysis. We obtained a batch of real samples from one of our customers. They analyzed those samples in the laboratory where the samples were analyzed was accredited under ISO 17025. And here you can see the results from that laboratory. The results are presented with dark blue bars. Our results with external calibration are presented with light blue bars, and with internal standard with yellow bars. You don't see reference results for some of the samples because the residue of 2-chloro of ethylene oxide and 2-chloroethanol, the residues were detected. However, they were below maximum residue level, so they were not quantified. However, what is important here, you can see that we obtained with our method, we can say almost exactly the same results as the accredited laboratory. However, what is important, they had to inject 2 microliters of extract. And we, thanks to the sensitivity of our instrumentation, we were able to decrease the injection volume to 1 microliter. And low injection volume is very important from the point of view of the robustness, because if we inject less, we introduce less matrix into the system. So we have less problems with maintenance, we have less problems with robustness. And to check the robustness, we decided to inject those 10 samples that you have seen on the previous slide. We decided to inject them over 3 days, again and again. So we injected the entire sequence 23 times. It means 230 injections. And during the sequence, we didn't change the liner, we didn't change the septum, we didn't retune the instrument. And you can see that the response of the instrument was very stable. All the samples were spiked with deuterated 2-chloroethanol, and we decided to use that compound to check the robustness. And here you have a graph. This is only every 10th injection, just to simplify the graph, but you can see that during the sequence, the response was very stable. And on the right-hand side of the slide, you can see the peaks, and you can see here that not only the peak area was stable, but also the retention times were stable, and the peak shape was not affected. You can see that at the beginning of the sequence and at the end of the sequence, the peak shape was exactly the same. So how can we summarize? We can say that thanks to our chromatography, thanks to the oven program, the column that we applied, we were able to get satisfying retention for both analytes, and we were able to separate them from interferences. Thanks to the sensitivity of our instrumentation, we were able to quantify the compounds at MRLs, injecting only 1 microliter. XL XR detector provided linear response from 7 to 16.5, from 7 ppbs up to 16.5. I have to explain that because previously we have seen that it was from 2 to 5, but in our extraction method, we had a dilution factor of 3.3. So we have to multiply everything by the factor 3.3. It means that 2 ppbs in the vial means that is 7 ppbs in the sample. And finally, the system was very robust over 3 days long unattending sequence. If you would like to know more details about the ethylene oxide analysis, I would like to invite you to read the application note that we prepared. We have also some other application notes related to the pesticide residue analysis with our new instrumentation with TSQ 9610. We have an application note where we described analysis of pesticides in baby food and pesticides in black tea. Okay, thank you very much for your attention.
Thank you so much, Dr. Lucas. So ladies and gentlemen, we have come to the Q&A session. And I know most of the audience that are currently listening in the platform could not wait to ask questions to Dr. Lucas. So if you have any question, please make sure that you put it into the Q&A chat box. So once again, we would like to remind that if you have any question, please put it inside the Q&A chat box. All right. So Dr. Lucas, the first question that we would like to ask after your presentation is, can we analyze EO with a single quad?
Well, it's a tricky question because it's possible. You can analyze, because if you go to a spectral library and you check ethylene oxide, you will see that this compound, obviously, like always with electron ionization, we have many fragments in the ion source. So you will find with your single quad, you will find 44 ions with mass, 44, 29, 28, 15, 14. However, we have to remember that all those ions are very, very small, and they are very, very non-selective, because if we have an ion that has a mass charge ratio of 12, what's that? It's only CH2. When we have I don't know, 28 is CH2O. Those ions are very small and very non-selective. They can be products of fragmentation of any other molecule that colludes with ethylene oxide. Working with a triple quad, we're providing much higher sensitivity and much higher selectivity, because we know that when we work with triple quad and we have a transition, and even if we are monitoring such a small ion like, I don't know, 28, we know that this 28 comes from 44, from the precursor ion of the ethylene oxide. When you work with a single quad, you should expect very high background. It means that you will have very low signal to noise ratio, and your sensitivity, your LOQ will be high. And we have to remember that, for example, in Europe, when we work with a triple quad, we need only 2 transitions. When we work with a single quad, we have to control 3 ions. So you need 3 very good peaks. And when we are talking about such a small ions, about the ions with such a small mass to charge ratio, is very easy to find some interferences.
I see. Thank you so much, Doctor, for the very detailed explanation on the single quad and also the analysis of EO. We have another question on the floor. It is, how do you prevent EO degradation?
Well, here we have to remember about 2 aspects: degradation and losses because of the evaporation. Degradation by itself is not so dangerous, because we have the residue definition, because we analyze ethylene oxide and 2-chloroethanol. So if there will be some kind of degradation of ethylene oxide, 2-chloroethanol will be produced, and we control both substances. But we have to be very careful during all the steps of sample preparation, because we want to avoid evaporation of ethylene oxide. And as we remember, ethylene oxide is very, very volatile. So we have to be very careful. For example, when we prepare the sample, milling is very important step. So maybe we can think about cryomilling. Means that we mix the sample with dry ice in the grinder, especially when we use a mechanical grinder. You know, the grinder has an engine that the engine can heat up the samples, and ethylene oxide can evaporate easily. So using the dry ice, dry ice protect from the evaporation. For example, in the lab, when I was preparing the calibration curve before the preparation, I took the vials, empty vials that I was going to use for the calibration curve, and I put them into the freezer, and then I prepared the calibration curve using very, very cold vials. And also during the analysis, I used cooling drawer. Cooling drawer is an accessory that you can use with our Tri-Plus RSH autosampler. Cooling drawer, we used cooling drawer instead of normal sample rack. So all the vials were stored in the cooling drawer in the very low temperature, in the 5 degrees Celsius. So the vials were stored below the boiling point of the ethylene oxide.
I see. Okay. Thank you so much, Doctor. Once again, we would like to remind all the attendees that are currently watching on the platform to put your question into the Q&A box or the Q&A chat box. Don't be shy. Please ask any question that you would like, and Dr. Lucas will answer your question accordingly. So, Dr. Lucas, which extraction method did you use?
Well, here the samples were extracted with Q oil. What is Q oil? Q oil is modified catchers, the catchers that was adapted to high oil matrices. And the difference here is that instead of using acetonitrile, the acetonitrile contains 5% of water, and in the cleanup step we have not only magnesium sulfate and PSA, but also we have C18. And the typical, if you go and search on the internet for Q oil method, usually the sample weight is 2 grams. In this case, we decided to increase the amount of the commodity that we took for the analysis from 2 grams to 3 grams. So we weighted 3 grams of, for example, the spice or any other matrix, and we extracted that with 10 ml of the extraction solvent. And this was the reason why we had the dilution factor 3.3.
I see. Thank you so much, Dr. Lucas. Since there is no question coming from the platform, Dr. Lucas, I would like to ask, do you like to add any more things to the session?
No, I think that's all from my side.
All right, thank you so much, Dr. Lucas. So, ladies and gentlemen, before we end the session today, we would like to say thank you for joining the session. If you have not visited our virtual exhibition hall and Thermo Fisher Scientific PTE Ltd virtual booth, we hope that you will spend your valuable time to explore their booth and our virtual platform and start networking with all of the industry key players that are currently participating in Lab Asia 2022. Also, don't forget to follow us on all our social media platforms for more updates. If you have any more further question, about the presentation that are made by Dr. Lucas, kindly drop the chat function in their virtual booth and do ask the question. So ladies and gentlemen, once again, thank you for joining and have a great day ahead. Thank you so much, Dr. Lucas.
Thank you very much.